Right, today's lesson, we're going to learn about esters, which are going to be one of the final functional groups that you have to learn. Now, the ester functional group, just slightly different to the carboxylic acid. So if you remember, the carboxylic acid had a C-double bond O and then an OH. Well, esters contain a C-double bond O and then an O bonded to at least one carbon. So the functional group is essentially going to look like, in the notes, I do have the notes attached at the end of this, but let me just load it up. Can't seem to find it. Where did it go? There it is. Right. So esters have the C-double bond OC group, so it looks something like this. Now let's just take it slowly to figure this out. An ester is formed from a carboxylic acid plus an alcohol. So carboxylic acid plus alcohol, so the two functional groups that we just did before, are going to form an ester plus water. Because water is the byproduct, it is a type of condensation reaction. Now, the condition required for this reaction to occur is that you need this concentrated sulfuric acid catalyst and heat. Now, what actually happens is slightly complicated here, but let's have a look. If we perhaps look at the picture version of it first. So this is the carboxylic acid. You need to know this particular ester is on your syllabus. You need to know its name and how it's made. So on the left, we have ethanoic acid. And on the right, we have ethanol. This is the key rule that you need to learn, and it will be very important when you do polymers as well. The carboxylic acid always loses the OH, and the alcohol only loses the H. When the H and OH combine, they form water, and this oxygen of the alcohol forms a bond to that carbon. So that's the bond you see right here. So this part of the molecule stays the same, then this C bonds to this O. That's the bond you see here. Then the rest of it stays the same. When you name this, you start from the bit after the single bond O. So you start from the bit after here. Now this has two carbons, and it's called an ethyl, the first time you've seen this. And then this part, from the carbon double bond O, is 1, 2. So it's ethane, and the ending of the esters is O8, like O8. So this one you really need to know the name of, ethyl ethanoate. This is the displayed formula that's used in the equation, which is perfectly acceptable, but you should also understand it with structural formulae. So here they've actually made a little mistake. In this particular note, this should say propanoic acid because it has 3 carbons. So this will be propanoic plus ethanol, which brings an interesting point. The name of this would still be ethyl, but then it'll be propanoate. Now, notice how the OH and the H combine to make water. Then this O joined to this O. So it all came in one line. Nice and easy. What we need to practice is how to actually form esters and how to go backwards. You'll need to understand vice versa. So this will explain it a little bit better for you. Esters are named from the alcohol and acid used to form them, and the alcohol part is going to be the ol, and the acid part is the anoic acid. Now, when you combine them together, the alcohol part makes an YL ending, like ethyl, methyl. Then the ester part is O8. Now, let me just show you what these methyls are. So CH3, C2H5, C3H7, methyl, These are called side chains if they come off something. Ethyl and propyl. You could carry on to butyl, but that's highly unlikely to come up in a GCSE setting. Let's have a look at these examples here. There's 3 examples. When these two combined, now what I don't like about, well, what you need to be aware of here is that swap the position. So these two are coming off each time. That's what's coming off. Now, when they combine, this oxygen is joined to this C, and that's when you're forming this. It's been twisted, so you got to take that into account. Now, this one, on the alcohol ending, will be ethyl and then propanoate. And the methanol part will be from this part here. It's 1 carbon. It'll be methyl, then 1,2-ethanoate. If you look at this one, we have 3, which is this part here. So it's propyl. Then it's only 1 carbon with a double bond. So it's propyl methanoate. That's how you name them. Now, they're not really going to ask you to name them. They're going to ask you to come up with the starting materials for forming the ester. So I'm going to go through a few examples on a white sheet of paper just to make sure you understand it. Just remember this part. Okay. Let's have a look. And then it's almost done. This is just a little fact. So let's just make sure that you understand how to go forwards and backwards. So I'm going to now draw some combinations to practice and just go through it. Now I'm keeping it nice by simply drawing it so they're lined up. So we're going to do these two. And we're going to do one more example. So this is the simplest carboxylic acid, methanoic acid. Then I'm going to do one backwards. So I'm just going to draw the ester here for you. And we're going to work that one backwards. Like what was used to form it. So let's start with the top one. The rule is you lose the OH and the H. Then they have to join together. So this part stays the same. Now this C joins to this O. That's the bit that's crucial. And the CH3 stays. So this will be called, starting from the single bond O, methyl, then 1, 2, 3, propanoate. And don't forget water will be produced too. Okay, example 2. OH comes off and the H comes off. We copy this. Then this C bonds to this O and then this C. So OC, COC, that's what that's spelled. Then you just copy these atoms out. To name it, you start after the single bond O. So it's got 3, which is propyl. Methyl, ethyl, propyl. And then 1 carbon, methanoate. The final example, we have to work our way backwards. So we break it here. We add an OH back to this because that's what it would have lost. So like this. No need for me to put all the H's there. And then when this breaks, an H adds back to this O. So the H is adding to this O. And the rest of it stays the same. So if you name this, First of all, you start here, ethyl, 1, 2, 3, 4, butanoate. Yeah, like butane, butanoate. And if you look at the splitting, the ethyl becomes the alcohol, so that's ethanol. And the butanoate becomes the carboxylic acid, so butanoic acid. And that pattern follows across. For example, propyl is propanol, metanoic acid is metanoic acid. Propanoate is propanoic acid, then the methyl is the methanol. Okay? This is the metanoic acid that comes from the methanoate. And the propyl makes the propanol. So the alcohol basically comes from the ill, and the carboxylic acid comes from the O8. Okay, that will be that. So I'm going to just complete it by putting my H's in and save this little screenshot for you. As I say, in exams, they don't make a big deal of the naming. They just expect you to be able to draw what's formed and how it starts. The only one that you're strictly supposed to know is ethyl ethanoate. But I would learn the nomenclature because it's useful. When I see methyl, I know it's methanol. When I see methanoate, I know it's metanoic acid. So let's save this. And now let's go back to the other screen. So the final thing that you have to know on these are actually going to be here. Know that esters are volatile with distinctive smells. So esters easily turn to a gas that's volatile, and they have a nice smell. They have a fruity smell. So they can be used in perfumes and flavorings. And that's what you need to know about them. So that completes the esters. So carboxylic acid plus alcohol makes ester plus water. And the one thing left for you to do next will be polymers. So we're going to go over addition polymers and condensation polymers. So see you next time.